All right, last time we talked about operator form, and we used the elimination method to solve systems of differential equations. To start with today, I want to point out something that's generally true about these types of systems of equations. So we've got some linear operator coefficient on x, let's call it L1, and then some other linear operator coefficient on y is equal to some function, f1. And then we'll do the same thing for some other equation, call this L3, x plus L4, y is equal to some function f2. All right, now if we were to solve this system of equations using elimination, or let's just get rid of our y. Notice what happens if we try to get rid of this y. Well, we're going to want to multiply the top by L4, and we'll multiply the bottom by L2, and then subtract the 2. And that will get rid of the y, because we'll have L4 times L2 times y minus L2 times L4 times y. Those will subtract to 0, and the y's will be eliminated. And so notice that what is always going to happen here is we're going to end up with L1 times L4 times x minus L2 times L3 times x is equal to L4 times F1 minus L2 times F2. All right, so in the future, rather than go through this whole process of multiplying the top equation by something and the bottom equation by something, we're just going to skip straight to this and eliminate the y by doing this and then move forward from there. So let's apply that now to our system of equations. So we've got x double prime of t plus y prime of t minus x of t plus y of t is equal to -1. And then we've got x prime of t plus y prime of t minus x of t is equal to t squared. So that's the system of equations that we're going to solve today. All right, let's first start off by putting this into operator form. So we've got the second derivative of x minus x, so that's going to be d squared minus 1 times x, plus the first derivative of y plus y, so that's d plus 1 times y is equal to -1. And then here we have the first derivative of x minus x, so that's d minus 1 times x plus just dy, and that's equal to t squared. So there we have operator form, and now let's eliminate the y by multiplying this times this, so we get d squared minus 1 times d. That's going to give us d cubed x minus dx minus these two multiplied together. D minus 1 times d plus 1 is d squared minus 1. So that's going to be d squared x minus a minus, so that's going to be plus x is equal to -1 times d. So it's d times -1. Remember, this means the derivative of -1. Minus d plus 1 times t squared. All right. So this is the triple derivative of x minus the second derivative of x minus first derivative of x plus x is equal to the derivative of -1 is 0, minus the derivative of t squared, which is 2t, so minus 2t, minus t squared. All right, so there is our equation that we need to solve for x. So let me put that up here, give myself some room, and we'll solve that. So now this is a third order differential equation, and we haven't really talked about higher order differential equations, but we can use the same methods that we used for second order differential equations to solve this. First, we're going to need to find the homogeneous solution. We're going to use our characteristic equation. That's going to be r cubed minus r squared minus r plus 1 is equal to 0. So there's a few ways that we could factor this. I'm going to factor this by grouping. And I'll factor out an r squared here. We're left with r minus 1. And factor out a negative 1 here. So minus 1 times r minus 1. And so we get r squared minus 1 times r minus 1 is equal to 0. So r is equal to plus or minus 1 or 1. So we have 1 and negative 1. So we have a double root at 1, and then we've got negative 1. Those are our roots of our characteristic equation, which means that our homogeneous solution is going to be some constant C1 times e to the 1t plus C2. And remember, when we had a double root, we have to add in another t here. So we're going to get t times e to the t plus C3 times e to the negative t. So there's our homogeneous solution. And now let's find our particular solution. Our particular solution, since we want this to equal something with t squared in it, our particular solution is going to be in the form a t squared plus bt plus c, which means that x prime is going to be 2at plus b, and x double prime is going to be 2a. And so the third derivative is just going to be 0. And then if we plug all this up into here, we get 0 minus 2a minus all of this. So minus 2at minus b plus all of this. So plus at squared plus bt plus c is equal to negative 2t minus t squared. All right, so that means, so we've got a t squared here, so a has got to be equal to negative 1. And here we have the t's, we've got negative 2at plus bt is equal to negative 2t. So negative 2a plus b has got to be equal to negative 2. And then our constants, we've got negative 2a minus b plus c has got to equal 0, since there's no constant term in on the right side of the equation here. Okay, so if a is negative 1, plug in negative 1 here, we get 2 plus b equals negative 2, so b is equal to negative 4. And if we plug in negative 1 and negative 4 here, we get 2 plus 4, so 6 plus c is equal to 0, so c is equal to negative 6. All right, so let's go ahead and put those coefficients in up here. This is going to be negative 1, this will be negative 4, and here we have negative 6. All right. So now that means that our x is going to be this homogeneous solution, C1 e to the t plus C2 t e to the t plus C3 e to the negative t plus the particular solution, so minus t squared minus 4t minus 6. So there's x. Let's put that up here. So x of t is equal to c1 e to the t plus c2 t e to the t plus c3 e to the negative t minus t minus 4t minus 6. All right. And we can go ahead and box that in. That's one of our answers. That's the solution for x. Now we need to find y. So the shortcut way to find y is, and this only works if there's a way that we can eliminate all of the derivatives of y so that we're only left with a y. And we can do that here. If we subtract, here we've got a y prime and here we've got a y prime. And there's no other derivatives of y. So we could subtract the second equation from the first, and then these will just subtract out and we'll be left with just a y. All of our derivatives of y will be gone. So let's do that. So we're going to get the second derivative of t, or of x, minus the first derivative of x. So d squared minus d times x. These will subtract to 0. These will subtract to 0. Plus y is equal to -1 minus t squared. So now we can just solve this for y. We get y is equal to, subtract this from both sides, we're going to get the negative of this. So this is d minus d squared times x minus 1 minus t squared. And now if we can just find the first and second derivative of x and plug those in, we've solved for y. So let's find the derivative of x. So x prime is going to be equal to, well, this isn't going to change, c1 e to the t plus c2 times, we need to use the chain rule here, it's going to be t e to the t plus just e to the t plus, and actually that's going to be a minus, so minus c3 e to the negative t. Wait, this should be t squared, right? Yeah. And so the derivative of that is going to be minus 2t and then minus 4. Okay. And then the second derivative is going to be equal to, again, this isn't going to change, plus c2 times, well, the derivative of this is just going to be all of this, plus another e to the t. So that's going to be t e to the t plus 2e to the t. This is going to change back to plus c3e to the t, negative t, minus 2. And so there we have our first derivative, our second derivative. So y is equal to this, minus 1 minus t squared. So y is equal to, this minus this is going to subtract to 0. c1 e to the t minus c1 e to the t. Those are going to be eliminated. So will these. So we have c2 e to the t minus c2, 2 c2 e to the t. So that's going to be minus c2 e to the t. If we subtract these, we're going to get minus 2c3e to the negative t. Minus 2t minus 4. See, did I mess something up here? No, minus 4 minus negative 2 is minus 2, right? then minus 1 minus t squared. All right, and we can reorder this a little bit. Let's put this t squared, so minus t squared minus 2t, and then the 2 and the 1 just become minus 3. And we'll call this y of t, and there's our answer. And that's it. So we've got our x of t is this, our y of t is this, and that's the solution to our system of equations.